Good day, students. Welcome to part three of the review for your midterm. In this section, we're going to be going over the law of sines, law of cosines, and also the area formula. Okay. Let's take a look at question number 11. It says, given triangle ABC with little a equals 8, big C equals 25, and big B equals 32, find little c. All right. So in order for us to be able to fully understand this scenario and accurately label our triangle, it's beneficial to make a sketch of the situation. Okay, so let's go ahead and make a sketch, not to scale, of what we're looking at here. Okay, all right, so there goes my typical triangle ABC. Let's label them using the correct fashion. So this is uppercase A, so that makes that little a. This is uppercase B, that makes this little b. The side opposite it, uppercase C, that makes it the side opposite little c. Okay, all right, so little a is 8. Big C is 25. 25. You put the angles inside and the side measures outside. So big C is 25. Big B is 32. And we have to find little c. So that's what we're looking for. All right, so let's look at the situation that we have here. We have angle, side, angle. Okay, so what do we use to solve angle, side, angle scenarios? Remember that um, in order to use the law of sines, we need a pair. So it comes in two fashions, either SSA or AAS. So anytime we have SSA or AAS, we use the law of sines. And then if we have SAS or SSS, we use the law of cosines. Okay? All right, so in this scenario, this is neither SSA or it's not any of these. It doesn't match. This is ASA that we have here. So since we do not have a match, then we have to resort to another approach. So let's see, what can we do to make it match one of these forms or to have a pair? Notice that we have two angles, so we can use the triangle angle sum theorem to figure out the last angle right here. Okay, and then we can be able to solve it using the law of sines. So let's go ahead and do that. So we're going to have to find angle A using triangle angle sum theorem. Angle A is going to be 180 degrees minus the sum of the other two interior angles, which is 32 plus 25. Okay, if we plug that into our calculator, we'll find out that angle A is equal to 123 degrees. All right, clearly it's not drawn to scale. So angle A is 123 degrees. So if you look at this scenario, we have a pair and a pair with a missing side. We have SSA situation, so we can use law of sines to find angle C. All right. So what are we looking for here? We want to find C, little c. All right. So to do that, we're going to use the law of sines, little c over sine big C. This is a pair missing a piece, and the next pair has to have no missing pieces, and that the pair that satisfies that requirement is the A's, or are the A's. Okay? All right, so we're going to have a little a over sine big A. All right, let's go ahead and substitute and solve for little c. So little c is unknown over sine. Big C is 25 equals little a is 8 over sine big A, which is 123. Okay? All right, now let's get a little c by itself. We'll multiply both sides by sine 25. So sine 25 on the left and sine 25 on the right. This divides out, and we're going to end up with little c equals. Now let's plug in that entire expression into our calculators, see what we get. So let's plug in 8, where it is, 8 sine 25 equals that divided by sine 123. Close that. Enter. Final answer is 4.03. So our answer is C, little c, is approximately 4.03. All right, so the answer to number 11 is option B. All right, so there you have it. Okay, let's take a look at question 12. So for question 12, we have to find the area of triangle ABC. Figure is not drawn to scale. So the area formula k, I'm going to write it k equals 1 half side times side sine of the angle. Okay, so there are three variations for this. Remember, you must have two sides and an included angle in order to do it. Okay, so if you have your triangle labeled correctly, the variations of this side and sine of the included angle is going to be k equals 1 half AB sine C, or 1 half BC sine A, or 1 half AC sine B. So it depends on what you're given. But if you label your sides SAS, you can just plug it directly into this generic formula right here. Okay. All right. So notice what I'm going to do here. This is, you're going to ask yourself, do you have an SAS situation? If so, you just take the two sides, multiply them together, 1 half, and then sine of the included angle. So here we have side, angle, side. All right. So following the order, side, angle, side, we can see that this can be directly applied to this formula, or this formula applies directly to this situation, okay? Um, so we're going to go area equals 1 half the side, which is 4, times the other side, which is 5, sine of the included angle, which is 61. Okay, notice I didn't use any of these formulas. I just used this generic formula right here. But if I wanted to be restrictive to focus mainly on the application of these formulas, let's label it. Let me show you the formula I'm using. So that's big B, this is little b. If that's big C, this is little c. And then obviously that's big A. So the version of this formula I'm using is 1 half BC sine A. Okay? Notice I didn't have to do this. Just knowing SAS is sufficient to use the formula. Okay? All right, so let's go ahead and plug that into our calculators and see what we get. Let's see. I'm going to do 1 divided by 2 times 4 times 5 sine 61. Okay, and the answer is 8.75 to 2 decimal places. So the area is approximately 8.75 square centimeters. All right, so the answer is letter A. All right. All right, let's move on to the next question, question 13. Question 13 says, given triangle ABC with little b equals 10, little c equals 5, and angle A equals 34, find little a. Okay, so what formula are we going to use here? I have absolutely no idea, so let's go ahead and draw a sketch of the situation, and then after labeling it, we can be able to determine the appropriate formula for the situation. Okay, all right, so let's make a sketch. Not drawn to scale. This is ABC. So that makes this little a, little b, little c. Okay, now little b is 10, so this is 10. Little c is 5, and measure of angle A is 34. All right, so what situation do we have here? We have side, angle, side. All right, SAS, law of cosines is what we're going to use here. All right, so the law of cosine is that we're going to select is the one that has big A. There's only one that has big A, and that is A squared equals B squared plus C squared minus 2BC cosine A. All right, so let's substitute and isolate a little a. So we have a squared equals 10 squared plus 5 squared minus 2 times 10 times 5 cosine 34. All right, let's plug that into our calculator. I'll have our calculators do the heavy lifting here. So let's see, what do we have? We have 10 squared plus 5 squared minus 2 times 10 times 5 cosine 34. Answer is 42.0962. So a squared is approximately 42.0962. So we're not done yet. We have to take the square root of both sides to get the value of a. So take a square root, take the square root. And if I plug that into our calculators, we're going to get, so we just gonna, I'm just gonna take the square root of the previous answer I got, and my answer will be 6.488. To two decimal places, it will be 6.49. All right, so measure of side length A is approximately 6.49. 6.49, okay? All right, so the answer to question number 13 is B. All right, now let's move on to the next one, question 14. Oh, that was 13. Sorry about that. All right, question 14. It says find the area of the triangle. So let's take a look at the situation that we have here. We want to find the area. If we want to use the area formula, we must have SAS, two sides and included angle, and we can use the formula K equals 1/2 the side times the side sine of the included angle A. Okay, SAS. What do we have here? Let's see what we have. We have S, S, A. SSA. This is no good. We cannot use this formula in this situation. In order for us to be able to apply this formula to this situation, we need to have at least an angle between two sides. So if I can find this angle right here, then I will have SAS using these two sides. Okay. So if we can find B, then we can use the angle, the area formula. Okay. All right. So let's write down the remark real quick so that we know what our focus is. So let me erase my labels so that we don't get confused. All right, I have two S's. I need an A. So let's write down the real quick remark. In order to use SAS formula for sines, this is the area formula for sines. For the given two sides, we need to find B. Okay, so in order to find B, we need to find C first. So we must find C first. Okay, so we'll find C first, and then use that to find B using the triangle angle sum theorem. Okay, so we must find C first, then find B. All right, let's go ahead and find, why did I choose to find C first? Because if you're looking at, if we're thinking of using law of sines, we have a pair here. This is an SSA situation, and if you have SSA, remember that law of sines. We have a pair here, the A's, and an incomplete pair, which is the C's, so that's the screaming law of sines. So what we're going to do first is we're going to find little c, okay, and law of sines is a choice here. So to find little c, we're going to go C over sine big C, and then the next pair has to have no missing pieces, okay? And A satisfies our requirement, so A over sine big A. All right, so now we're going to substitute and solve little c over sine big C. Actually, let's see, what are we looking for? We're looking for a big C. So let me restructure this. This formula is correct, but I kind of messed up my cases. So I'm going to go we want to find big C, we know little c. Okay, so to find big C, I'm going to switch it around a little bit. So sine big C over little c has a missing piece, which is big C over sine big A over little a. I like to place the variables I'm looking for on top. All right, so let's substitute. We have sine big C, little c is, let's see, let's label our triangle so we don't get confused. If this is big A, this is little a, and then this is little c, okay, and then this is little b right there. All right, little c is 9 equals sine A, 65, sine 65 over little a is 20. All right, now to get sine c by itself, we'll multiply both sides by 9. So multiply by 9, multiply by 9. Let's divide out. We have sine C equals, let's see what we get when we compute 9 sine 65 over 20. So let's do that. So parenthesis 9 sine 65, close that, divided by 20. Final answer is 0.4078. So sine C is approximately 0.4078. 0.4078. And if we get C by itself, we simply take the inverse sine of both sides. So big C is approximately the inverse sine of 0.4078. Plug that into our calculators. Let's see what we get. So we're going to do the inverse sine of, let me just use the previous answer, second function negative. So plugs in my previous answer, 24.0691. Okay, so big C is approximately 24.0691 degrees. Okay, now let's see if that's big C, 24.0691. Let's put that in here. 24.069. Now what is big B? We can simply use the triangle angle sum theorem to find it. Okay, so let's do that. To find big B, we're going to use big B equals 180 minus the sum of the two other angles, which are 65 and 24. So minus 65 plus 24.0691. So big B is going to be approximately, this is going to be an approximation since big C is an approximation also. So I'm going to go 180 minus parenthesis 65 plus, I'm going to call up my previous answer, second function negative, enter, and angle C is 90.93, 90.9308. Okay, so let's use that, 90.9308. So let's write that down. Angle B is 90.9038 degrees. Now, what does that mean? Is the question. Well, let me just fix something real quick. It's 9308, not 9038. 9308. Okay. Are we done? Absolutely not. We're looking for angle B because that can help us find the area. So 90.9308. So now we can now use the SAS formula using little c, little a, and big B to find the area. Okay. So we're going to use the formula, find area now. To find the area, we're going to use the formula K equals 1/2 AC sine B in this situation because we have SAS. So that's going to be 1/2. A is 20. C is 9. Sine the angle we got, which is 90.9308. Let's plug that into our calculators and see what we get. So we have, let's see, 1/2, 1 divided by 2 times 20 times 9 times the sine of, did the wrong function, sine of my previous answer, negative, enter. We have 89.988. Let's see our options right here. We're gonna round it up. So if you round up 89, it automatically becomes 90 square inches. Okay, so the area is approximately 90 square inches. All right, so the answer is option, for this problem is option letter B. Okay, let's go ahead and consider the next problem, question 15. Question 15, it says 3 ships are at sea, Admiral, Barstow, and Cauldron. Okay. The crew of Admiral reports that an angle 33 degrees is found between the line of sight and Barstow. and the line of sight and color. So it looks like we have 3 points here. Let's go ahead and draw 3 points. I cannot draw to scale, obviously. I'm going to let A represent Admiral, B represent Barstow, and C represent Cauldron. Okay? Alright, let's formulate a triangle, and then we're going to populate the measures using the information in this paragraph. Okay? So we have a triangle situation. So we're now starting from Admiral. Angle of 33 is between Barstow and Cauldron. So this is 33 degrees right here. Between Barstow and Cauldron, this angle right here. Okay? Alright, and then uh, it says it's found between that and then the radio Barstow, and by comparing all landmarks, find that the distance between Admiral and Barstow is 617 meters. So between Admiral and Barstow is 617. And it says the Barstow reports that an angle of 53 is found between the line of sight to Admiral and the line of sight to Cauldron. So between Admiral and Cauldron, the angle of separation here is 53 degrees. Alright? So it says to the nearest meter, what is the distance between Barstow and Cauldron? So what is this distance right here, which is little a? Okay, so that's what we need to find. So if you look at what we have here, we have an ASA situation. So whenever I have ASA, we can convert it into an SSA situation. Actually, an AAS situation, because we can always find the third angle. So just like this, we have no pairs, you see? So we can't use law of sines, and this is not SAS nor SSS, so we can't use law of cosines either. But you notice we can find angle C. Okay, so let's do that first. Find big C so we can apply one of the laws that we know. So to find big C, we're going to use big C equals 180 minus 53 plus 33. Okay, if you do that in your calculator, you get 94 degrees. So this is 94 degrees. All right, so if you look at the situation that we have here, we have a pair that we know and a pair with a missing side. So that tells us that we can basically use AAS. You see that? AAS? Law of sines will work here. All right, so let's go ahead and solve this problem. To do that, we're going to indicate what we're looking for, which is little a. So we want to find little a. Little a is the distance between Barstow and Cauldron. Okay, so to find little a, we're going to go a over sine a equals the pair that we know, whether it's C, little c over sine big C. Okay? All right, now let's put in the measures that we know. A, we do not know, over sine big A. Sine big A is 33 equals little c. Little c is 617 over sine big C. Big C is the measure we just determined as 94. Okay? All right, now let's times both sides by sine 33. The sine 33 on both sides. All right, and these two cancel out. And then let's plug this into our calculator and see what we get. C. So we have, clear that, 617 sine 33 divided by sine 94. All right, answer is 336.86. Let's see how many decimal places. Well, we're going to round it to the nearest whole number. So let's see. If we round it up, it's going to be 337 meters. Okay, so A, the distance between Warsaw and Cauldron, is approximately 337 meters. All right, so our correct answer for this is option letter C. All right, let's take a look at question 16. So it says, given triangle ABC with A equals 11, B equals 12, and big A equals 39 degrees, find little c, round your answer to 2 decimal places. So what we're going to do here is draw a graph of the situation. I mean a shape of the situation. So there goes my standard triangle ABC. Let's see. This is not drawn to scale. Call this A, B, and C. And that's big B, that's little b, that's big C, that's little c, that's big A, that's little a. So little a is 11, little b is 12, big A is 39. Okay, when we're asked to find little c. All right, so let's see what we have here. We do not have any of the pairs for angle C, so we cannot find it directly. We have to find it indirectly. We have a pair for A and a missing pair for B. So the strategy here will be to find big B first, and then find big C, and then use that to find little c. Okay? So that's the step. All right, so let me just summarize it right here. So we're going to find big B, and then after finding big B, we can use the triangle sum theorem to find big C. And after finding big C, we have a pair. And here's the other pair for A to find little c, which is what we're looking for. Okay? All right, so let's do it step by step, starting out with finding big B. All right, so to do that, I'm going to go sign big B over little b equals the next pair we need to have both pairs accounted for, a complete pair, and A satisfies that, so we have sign big A over little a. All right, let's substitute and solve for for big B. So we have sine big B, little b is 12 over 12 equals sine A, sine 39 over little a, which is 11. All right, now we'll multiply both sides by 12 to isolate sine B. So this divides out, and then we have sine B equals, now what we're going to do is we're going to plug this into the calculator to see what the value of sine B equals. Okay, so let's go ahead and compute that. Parenthesis 12 sine 39 divided by 11. So it's 0.6865. So sine B is going to be an approximate value, so let's use the right inequality symbol. So sine B is approximately 0.6865. So to get B by itself, we just simply take the inverse sine of both sides. So we have the inverse sine of 0.6865. All right. So let's plug that into our calculators and see what the value of angle B is. So inverse sine, oh, it's not working. So inverse sine of the previous answer, second function negative. Answer is 43.3562. All right, so let's write that down. Big B is approximately 43.3562 degrees. Now we're done with the first step. Now let's put that into our diagram so we know where we're at. So 43.3562. Now we can use the triangle angle sum theorem to find C. Okay, so using that information, we have big C equals 180 minus A plus B. A is 39 and B is 43.3562. All right, so big C is going to be an approximate angular value. Let's see what that is. Plug it into our calculators. 180 minus parenthesis 39 plus, I'm going to insert the previous answer, close that, enter, 97.643 6438. Okay, so angle C is approximately 97.6438 degrees. Okay, all right, almost there. Last step, we're gonna now look for find little c, because we have one of the pairs for the c's that can help us find the missing pair. Okay, so to find little c, we're gonna go little c over sine big C equals I can use the B pair or the A pair. The A pair is more exact and neat, so I like to use that one instead. Okay, A over sine A. This is the formula I'm going to use. All right, so little c over sine big C. We just found sine big C as being 97.6438 equals little a, which is 11, over sine big A 39. Alright, so to get little c by itself, we need to eliminate this denominator, so multiply both sides by sine 97.6438. And then this is 11 sine 97.6438. This divides out. So your final answer, little c, it's going to be an approximate value. So let's go ahead and compute what that is. It's going to be 11 sine, previous answer I'll insert, answer, divided by sine 39. What was that? And our final answer is 17.32. So two decimal places. So it's approximately 17.32. All right. So our answer is option letter D. Option D will be our answer here. Okay. Now let's move on to the next question. Last one for this section. Question 17. In this scenario, it says this is an approximation of the area covered by New Hampshire using a triangle. So it says the state of New Hampshire is approximately triangular in shape. Use the diagram shown at the right to estimate the area to the nearest square mile. So remember the area formula K. If you have SAS situation, you can use the formula K equals 1/2 the first side times the second times the adjacent side sine of the included angle between the two sides. Okay, so let's see if this if we can apply this formula directly to this situation. So we have a side, we have an angle, and we have a side, SAS. All right, so guess what? We can apply this formula directly here. We don't even need any formulas to do this. We don't need to label it A, B, or C. So we're going to go K, area is 1/2. The first S is 88. The second S is 194. Sine 86. All right. So let's plug this into our calculator and see what we get. So we have 1/2 times 88 times 194 sine 86. All right. So we'll plug all that in. Answer is going to be 85.2067 square miles, but we're running it to the nearest integer. So our area, approximate area for New Hampshire is 85.8515 square miles, and that is to the nearest integer, and that is option letter D. All right, so there you have it. But thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel by clicking up here. And if you like this video clip, you can click like. Please post a comment to tell me what you think about this presentation. More clips coming from marketserve.com. Thanks again and have a wonderful day.